Good day, folks. Happy Friday. All right. Today I'm not here, unfortunately. Yeah, I Wednesday was tough. But hey, just a couple of things uh before I teach y'all about simplifying radicals. If you've emailed me about getting points on the test, if you made a silly mistake and you're requesting points because after you submitted it, you've seen that you needed to round to a whole number or something like that, I'm not going to go through and go back and give you points. Okay, y'all need to retake it if that's the case. I have been talking to the librarian and she's going to be able to set up retakes for y'all's. If you need them. Now, that's on the Unit 7 test. And also, if you haven't taken the Unit 7 test, Miss Reese will be able to help you out with that. Okay, so don't, just a heads up, don't ask her about Unit 8 retakes. Okay, I haven't figured out what I'm going to do with those quite yet, but I will let you know probably in a future video what I'm doing with those, or if I do make it to school. I'll let you know what we're doing with the Unit 8 retakes. Okay. But if you want to fill out a retake form, just email me a picture of the retake form and I can get your name down so that you want to for retaking the Unit 8 test. All right. So now that's out of the way. Let's get started with this. Whose dog is that? All right. Anyway, so simplifying radicals is awesome. It's radical, right? So a radical is pretty much a square root. Okay. It's another name for radical, right? So as you may see here, we don't know what the square root of 24 is. It's an irrational number, right? But we can still simplify it so that we can work with that number so we can use parts of it, all right? Now, the starter today, oh geez, I don't have that up on there. The starter today, what I was going to have y'all's do was, not that, hang on. Yeah, I was going to have y'all's do this. List all the factors of each number. Okay, understanding factors of numbers is key to simplifying radicals, all right? So 51, for example, right? Factors of 51 include 51 and 1 and 3 and 17. Now, if you've forgotten what a factor is, factors are numbers that when you multiply them by each other, they will equal that number. So it's numbers that can multiply into another number. So 51 times 1 equals 51. So both 51 and 1 are factors of 51. Okay, 3 times 17 will also equal 51. So 3 and 17 are also factors of 51. If you want to pause the video and look over this a little bit, that's totally fine. But yeah, for example, like 12 has a bunch of factors. We've got 6 and 2, 12 and 1, and then 3 and 4 are all factors of 12. 64 has a bunch as well. Okay, again, this is really important for simplifying radicals because we are going to find all the factors of a number in order to simplify, well, of the number within the square root sign in order to simplify that radical. Let me show you all what I mean. Okay, so we're simplifying the radical square root of 24. So first thing we need to do is make a factor tree. And as I'm writing this down, y'all should be writing this down as well on this piece of paper, okay? And don't recycle these. Hold on to them because you can use them on your worksheet or on practice problems in the future. I don't think there's going to be practice problems tonight, but you can still use these in the future. Okay, like tomorrow or not tomorrow, the next day, but like Monday or Tuesday when we're working with this again. Okay, so you're going to make a factor tree. Y'all have done this before. I can't remember if it was 5th grade, 6th grade, or when it was, but think of some numbers that multiply to equal 24, right? So for example, let's think, oh, I got one, 2 and 12. Great. Okay. Now, as you work down the factor tree, you see you've got those branches, right? Our little branches here. Okay. You're going to keep working down. 2 doesn't have any more factors. I mean, it's got 2 and 1, but we don't need to put those on there because we could technically do that forever, and that doesn't really help us out. So once you get to a number that has no more factors other than itself and 1, you can stop. Okay. at least on that branch. But 12, we've got a few more. We've got 3 and 4. 3 is just the factors are 3 and 1, so we don't need to do that. 4 has 2 and 2. Okay, perfect. Now, once you've made your factor tree, like this right here, such a nice factor tree, you're going to circle the pairs. All right, so for example, 2 and 2, that's a pair. Okay, there's 2 of them, right? You don't have to do them from the same branch though as well. Like we could circle this 2 and this 2, okay? Right? They don't have to be kind of next to each other, all right? So we'll circle 2 and 2. Actually, let me use a different ink for that. It's a bit easier to see. So we've got 2 and 2. Okay. And then you're going to underline the singles. Underline the singles. Okay. So for example, when you're looking for the singles and the pairs, you are looking at the ends of the branches. So we're not looking at 12 because there's stuff that comes out of 12. That's not going to be included in a pair or a single because there are factors coming out of it. We're not looking at that. We're only looking at the ends of the branches. So 2 right here, that's a single. There's no more 2s to match it with. And 3 here, there's no other 3s. Okay. Now, this is the fun part. Okay. The pairs, well, pairs, you know. Pairs. Okay. I'm going to make the connection to couples, right? Pairs go outside. And you'll see what I mean in a bit. Okay, the pairs go out, right? When you're a couple, you can kind of go out to movies or to dinner, something like that, right? Okay, so they're going to go out. Okay, and the singles, where it's really at, they stay in. I don't need to go out. I can watch Netflix on my own or make myself dinner or, you know, who knows, have a dance party in my own living room. Whatever it is. Okay? Singles are going to stay in. Now, what I mean by that is when we have, so at the end, you're going to end up with another square root sign. Okay? The pairs go in, or the pairs go out. So there's a pair of 2s, so 2 will be out. Okay? The singles stay in. We've got 2 and 3. Okay? So do you see how when we've got pairs, right? I'm going to use this as a pointer. Okay? When we've got a pair, they go out as a pair. So there's just one of them outside. Okay? The singles, right? 2 and 3 stay in. Okay? And we actually multiply the singles. All right? They stay in. We multiply them. And we end up with our number. So step 6 is to multiply singles. And if there's multiple pairs going out, you can multiply those as well. So there aren't multiple pairs, so there's no multiplying happening. Right? But the singles, there's multiples of them, so they do multiply. And we have 2 square root 5. Okay? Now, funny thing is, if you enter in your calculator the square root of 24, you will get a number. All right? Let's find out. Hey Siri, what's the square root of 24? Okay, so that's equal to 4.8989, roughly. All right? Now, if you enter in your calculator the square root of 5 multiplied by 2, you're going to get the same number, 4.8989. Give it a go. Try it. Okay? What that means is these are the same things. Okay? 2 times the square root of 5 is the same as the square root of 24. Okay? The reason we simplify radicals is so that we can work with those numbers, right? If I was trying to figure out what 4 times the square root of 24 is, well, that's kind of hard to do, right, in my head. But because I can't really multiply by a radical unless I figure out what that number is. If I was trying to do 4, but if I do 4 times 2 times the square root of 5, well, I know that's about 8 times the square root of 5. Okay, so pretty much the point of simplifying radicals is it makes it so that you can work a little more with those numbers, okay, which will come up in high school, right? This is a skill you want to have for higher level math. All right, so what I want y'all to do now is on the back, you've got these example problems. I want you to give these a go, okay? So pause the video, give them a go, and then I'll go over them in a bit, okay? You better be pausing the video. If you're not, find out. All right, so we've paused the video. You've probably unpaused it. You've tried these out on your own. Let's work through a few of them, okay? So first off, let's look at 72. Now, if your factor tree doesn't look exactly like mine, that's okay, right? 72 could be split into, what is it? Oh my gosh. Don't have a calculator. We're going to have to do this. All right, 72, 3, yeah. So 2 and 36. Okay, now you could also probably do, well, your factor tree might have started out with 12 and 6 because 12 times 6 equals 72. All right, I'm going to stick with 2 and 36 just for me. Okay, now, if I continue with my factoring, I've got a 6 and a 6. Okay, now I could stop right here because I've got a pair and a single, right? And there's nothing coming out of that, okay? So this can be written as pairs go out, come here, all right? And the singles stay in. This could be written as 6 root 2. Now, if you kept going, that's okay. You should get the same answer, right? For example, 6 is 3 times 2 equals 6, and 3 times, let's do this, 2 times 3 equals 6. All right, so if we're going through this and we're circling the pairs, right, we've got a pair of 2s and a pair of 3s and then a single 2. So if we stick with our rule, right, our next step, we let the pairs go out, 3 and 2 go out, and 2 stays in. And then we do step 6. We multiply the pairs and the singles. Right? So the pairs, 3 times 2 is 6, and the single is 2. There's nothing to multiply. You see how we get the same exact thing? Okay? So if you don't catch that pair right away, that's okay. Doesn't matter, right? Worst case scenario, you just do a full factor tree and you end up with the same answer. Maybe you did a little more work. That's okay. So that first one is 6 times the square root of 2. All right, let's look at number 2. I don't want this video to be too long. Where are we at? 12 minutes, that's fine. All right. So 54, that splits into, the obvious one would be 9 and 6, right? 9 splits into 3 times 3 is 9. 3 times 2 is 6. We've got a pair of 3s. The pair goes out. We've got a single 3 and a single 2. They stay in. And we do our final step of multiplying. Right? We've got nothing to multiply the 3 by, so we're good. 3 times 2 is 6, so this is actually equal to 3 times the square root of 6. Look at that. It's amazing. Okay, fantastic. Now, 12, I think, ended up being, if I do 12, if you're still not understanding it, I'll do the rest of them, okay? Follow along. All right, but I want y'all to try these after each one. If you think you understand something, try it on the next one, see if you got it right. Okay, so 12... we've got 3 and 4, and 4 is 2 and 2, right? So circle the pairs, underline the singles. The pairs go out, the single stays in. We multiply if there's more of them. There aren't. So that one is just 2 times the square root of 3, all right? This one's great, okay? What is the square root of 64? Well, it's 8. So if you end up with a perfect square, you don't need to simplify that radical. Okay, because if you simplify it, you'll still end up with 8. Check this out. So 64 is 8 times 8. Oh, look, a pair. And nothing else. Pair goes out. There's nothing to stay in, so nobody's staying in. Everybody's going out that time. All right? So if you run into a perfect square, celebrate, because that's awesome, right? You don't have to do any more work. You know what the square root of 64 is. So you don't have to do a factor tree. All right? 36, we've got the same thing. Okay? Square root of 36 is equal to 6, so I don't have to make a factor tree. I'm all good. All right, now I would double check these on your calculator. If you're not super comfortable with perfect squares, double check these on your calculator first. If you get an irrational number, then you need to make a factor tree. If you don't, then you're good. All right, so the square root of 45, this one separates into, let's do something interesting here. Let's do 45 is 5 times 9. Let's do 15 times 3. Let's get crazy, all right? 3 times 15. All right, now 15 separates into 3 times 5. I can't pick any more factors out from those two, so I'm not going to. I'll circle the pair, okay? Real important here, this pair is not, they're not at the end of the same branches, and that's okay. We don't have to be. All right, we've got a single 5. The pairs go out. The single stays in. Ta-da! We have 3 times the square root of 5. Okay, so the more comfortable you get with this, the easier it becomes. And it might even be that you get to a point where you don't need to do a factor tree. Okay, you might know that, oh, 9 times 5 is equal to 45, and the square root of 9 is 3, so 3 times the square root of 5 equals the square root of 45. You can get to that point. And if you're feeling really comfortable with this, I encourage you to try that, but check your answers, okay? This will be on the rise. So I do want y'all to know how to do this, okay? And also, you'll need to know this going forward into high school. Plus, when we do the lesson on Monday and Tuesday, when we're adding and subtracting, multiplying, dividing radicals, okay? Simplifying radicals is a great base. All right, so that is the lesson for today. What I want y'all to do is make sure you're getting that other worksheet done, okay? And hold on to that as well. There's notes at the top of it on how to do it. There are some numbers that have variables in them. I want you to try those, okay? See how you get along with them, right? So actually, I'm going to show you one. So let's say we had a variable in this. Let's say it was a squared, okay? Actually, let's do x squared because that's more fun. Actually, yeah, let's do x squared. Okay, so if you did have a variable in this, you're doing it the same way, right? 45 splits into, well, you're going to make a few different factor trees actually on this. So 45 splits into 9 and 5, which splits into 3 and 3. And then you've got to make a different factor tree for the x. Well, x squared is equal to x times x. Simple enough, right? We've got a pair of 3s, a pair of x's, and a single 5. So the pairs go out. We've got 3x out, and the singles stay in. That would be your answer for that one. Simple enough. Okay, the variables kind of make it, it's just an additional thing to do onto this, right? It's not a lot of extra work. Okay, now that one works out well, but let's say we had x to the third. Okay, so if we're doing that, we've got x times x squared or x times x. Now we have a pair of x's here, but we also have a single x. So what that's going to look like is, well, we'll have the pair of x's go out, right, like they did, and then a single x staying in. That's the only way that's going to change our answer. Okay, so the same rules apply, same steps apply with variables. The only difference is with variables, you will have to make a separate factor tree for the variables. Okay, hope you all watched the whole video. That's 18 minutes. Should have a good extra 20 minutes in class, all right? So take it easy, good luck, and we'll see y'all next week, all right? Bye-bye. Ooh. Oh. All right.